We are Project Altair, the rover team from Islamic University of Technology, Bangladesh. We are competing at the European Rover Challenge 2023 Remote Edition.
This year, for ERC Remote, our team consists of mainly two sub-teams. The software sub-team that works on the challenges and the tasks, whereas the fear sub-team that works on the media outreach and presentation.
We are a newly formed team, which is a result of the merger of the two previous Mars rover teams of our university. Both teams have numerous instances of success in global rover competitions.
We believe ERC Remote is a great platform for our software sub-team. We can focus on automation development without getting limited by hardware. We can show off our software engineering skills, and we can achieve something very great without getting limited by hardware.
We subdivided ourselves for maintenance and navigation tasks. In case of navigation, we decided to use the simulation instead of 3D printing the ExoMy rover because of resources issues.
We had to learn various functionalities of ROS, MoveIt, Gazebo simulation, and OpenCV. We studied their documentation and started implementations. We are gradually developing the softwares through test and iteration process using simulation. The information and experience we got from the test drives are also very helpful.
Now, we'll talk about our approach to this year's navigation task. As this year's navigation task is completely manual, we face some new challenges which we had to solve.
As we need the distance estimate to the Aruko markers to properly execute the objectives, we automated the detection process through a Python script. The script takes the screen feed of the navigation UI. Then, we are parsing the camera feed portion of the screen and feeding it to the OpenCV methods to parse the Aruko tag and output the distance of the rover from the landmark. We experimentally acquired data on the actual distance from test drive 1, compared it to our calculated distance through the library, then adjusted the offsets in our Python script. We developed our own Gazebo simulation for the ExoMy rover. We took the Gazebo world from the previous year's ERC simulation and used it as the world in our simulation. It helps us to practice driving on terrain and test Aruko pose estimation.
We are preparing for an autonomous approach to the maintenance objectives. There were two main challenges for us to solve: motion planning of the arm, detection and pose estimation of the Aruko markers. We are using the ROS MoveIt for motion planning. For Aruko markers, we are using the Aruko Detect ROS packages. Here is the ERC arm performing some of the objectives autonomously in the simulation.